Welcome to Studylitcs Labs. Myself, Dr. Pulla Sammaiah, Professor and Director, Center for Metals and Manufacturing, Department of Mechanical Engineering, SR University, Warangal, and also founder for Studylitcs Labs. My experience is 25 years plus. Like, share, and subscribe my channel. Welcome to Studylitcs Labs. This is the FDM printer, Fusion Deposition Modeling we call. And this is especially used for printing the low temperature polymer materials. We can design based on the CAD profile. The critical components also this is the panel which we can give the input parameters into the printer panel so that we can set. Yes, this is already inbuilt. There are two ways here. This is the inbuilt diagram and already saved diagram. Other one is you can use the USB port, take the new one. So then you set the parameters. So that is the infill density, uh, then layer thickness and the printing speed and everything you have to design in the panel, the printing panel. So then the printer adjusted in X and Y Z directions, in the three directions. Then according to your CAD profile, the setup is a moving, or the platform can move in X and Y and Z directions. So that's what you see, that the panel you have to straight rising. Then the printer you have to connect with the filament, the back end of the 3D printer, you connect the filament, and the filament you have to start printing here. Is started printing. The filament slowly we are through the servo motors. Then you feed the metal slowly and starts getting layer by layer printing on the platform. Accordingly, according to your CAD profile, in X and Y, Z directions, the printer can move. You see in all the three directions. It's a very fantastic that material called the ABS. That material we can use to design the a small tray we are given. In the CAD file, we have designed a small tray. Then according to the dimensions, the printer can move. And the infill here is infill layer. Our infill densities we are given a 40%, 60%, 80%, 100%. And here we are given the 60% infill density because to reduce the time to develop the product within the time. And also the layer thickness we are given only 0.1 mm thickness we are given here. That's what the finishing levels are very good. Then you see here the panel again, the almost 30% is completed. So this panel is showing how much percentage you are completed on the platform or product you are developed. That percent is around approximately 30 to 40% is completed. Now you see that again is a moving according to that directions of the CAD profile. Then you see that the distance between the product and the nozzle end is only 0.1 to 0.3 mm gap. In between, you can just fill the material. So, uh, according to your printing height, the nozzle can adjust it. Then you see in all the directions is moving. So, this is a fantastic 3D printing process here. We can develop any critical component or any critical shape we can design very easily by using the 3D printing process. Especially in a Studylitcs labs, we try to develop many models using this FDM process, FDM printer. This is a very low cost 3D printer, and we can develop any critical component by using PLA material or ABS material or nylon material. There's all these materials we can use comfortably in the 3D printing process. That's what, dear friends, you can see the component consists of many different shapes and diameter, very small diameter holes are there. But you see that's very accurate. That precision we are getting by adjusting the parameters within the 3D printing system. So before that, in a CAD, you have to design by using the Fusion 360. In the file, you have to create properly. Is there any errors are there? You can adjust there itself. Now, not only that, in our SR, my university where I am working as a professor in a mechanical engineering SR university, that SRU symbol also we designed on the component. very minute, but the dimensions are very accurate. We are received. Uh, Dear friends, here one more thing is, uh, yeah, almost the product is completed around, yeah, you can see now again, yes, 80% completed. Only 20% remains. So then again, almost the product is completed 80%. You can see SRU, the symbol is visible very clear. Yes, is almost finished, and the product is with a high quality and with ABS material, and all the dimensions uh, we have finished. So after that, what we did is whether we achieved or not of our whatever we designed, yes, exactly is matching with our original dimensions of the product. So whatever we are given in the CAD file, yes, we are getting is almost 95% is almost is going to complete. Yeah, is almost 100% completed. The product you can see here very clear. Yes, the product is completed almost. Yeah, see, that is a very good quality with all the dimensions, very thin cross sections we covered, an entire product. That's what the lab we can did many different kind of models we can develop by using 3D printer. 3D printer we have in our Studylitcs Lab Private Limited. That's what there are many orders are given by the different agencies or companies. So we try to develop the products and give it to them. So dear friends, now you see that the product is, yes, how is moving in X, Y, and Z directions. So the Z is the thing is completed, the product is. That slowly is moving upside, the nozzle. The distance shows very clear here, is almost 100% completed. This is the 3D printing process by the FDM to develop the product using the ABS material. Dear friends, this is the final product. Yeah. Yes. Now we can see here. Thank you for watching my video.